star was 61 Cygni. Here's how it works. If you recall, the maximum baseline for parallax measurements for planets was the diameter of the Earth. For stellar parallax, we have the diameter of the Earth's orbit around the Sun. That's an increase from around 13,000 kilometers, or 8,000 miles, to 300 million kilometers, or 186 million miles. That's 23,000 times larger. So from one side of the Earth's orbit, say in July, we take a line to the star and map the positions of the more distant stars. 6 months later, in January, we repeat the process. This gives us the angle theta. We define stellar parallax as 1/2 this angle. This would be the angle at the star with the Earth and the Sun making the other two corners of a right triangle. The math is the same trigonometry we used for finding distances to the rock in my backyard and to the planets in our solar system. Of course, this is an oversimplification. Frederick Bessel mapped 61 Cygni against the distant star background for 28 years, observing the star's ellipses that followed the Earth's orbit. In 1838, after thousands of measurements and calculations, he made scientific headlines by announcing that the parallax of 61 Cygni was 0.314 arcseconds. That gives us a distance of 98 trillion kilometers. That's 61 trillion miles. Way too far to be reflecting the sun's light. So at this point, in the middle of the 19th century, we knew that stars burned with their own light.